Hi, I'm Ben Hansen. I'm an industrial designer, recently studied at Newcastle University. I'd like to talk to you about Regen Lens, my new product for my design company, Defender Optics. Regen Lens is a new way of maintaining PPE. They are safety glasses that have detachable lenses so that you can maintain the frames without but still having a fresh pair of lenses.
What I would love to achieve with this product is that it changes the way we see PPE. It's no longer a discardable piece of clothing or protection or bit of armor. It becomes a tool in the workshop. It becomes something that can be sharpened, refreshed, reused, and we can gain an emotional connection to it even. The target market is a hazardous workplace with 25 people or more, so the larger work sites. These sites could include construction, general manufacturing, metalworking, defense. And the lenses themselves, they actually choose polycarbonate, which is a remarkable material. It is affordable, it is powerfully strong. It's not powerfully strong, but it is able to absorb the force and fracture rather than shatter, which has defended many eyes. The fatal flaw in polycarbonate is that it scratches very easily. I did an experiment. The experiment was to wear 3 pairs of glasses, one that was untouched, one that had heavy scarring, and one that had light scuffs, and to see the effect that it had on me. For the untouched lenses, I actually subconsciously took them off at around the hour-and-a-half mark, on average, of 5 times. And for the heavy scars or scratches, I ended up taking them off every 20 minutes. And for the light scuffs, I actually ended up taking them off every 15 minutes on average.
My name's Ben Percy. I've been a technical officer in the workshop here for close to a year now. I've worked casual contracts within here for over the last 5 years, throughout studying and also working as either a casual teacher or as a furniture maker. If you've got scratch marks on your lenses, then it's definitely distracting. Probably more so in sanding on timber. So when you get down to working down to 243, 320 and 400 grit, you're trying to find scratches on the timber to sand out, and if you've got scratches on your lenses, then they do give you a bit of a false reading, and it's much easier to work without them on if you've got scratches.
To help me design this product, I computer modeled all of my parts. I computer modeled all of my parts and 3D printed them, and using MakerBot software. Another thing I 3D printed were ergonomic heads. To understand the ergonomics that I would have to achieve to make these glasses fit as many people as possible. One of those heads were, in fact, mine. I 3D scanned my own head and put some glasses on it. It was a very weird experience. I was going for a 2-buckle system on each side, but as I was analysing the way that the buckle clicked in with each other, I thought that this buckle could actually be the whole lens in the end and could flex outwards and click into the frame. To make the product more intuitive with the snap locking mechanism I put in it, on the side there is a thumbprint which I gained influence from a thumb pushing in clay and leaving an impression. And what that is saying is that there was a thumb here and there could be a thumb there again. The snap lock design in the safety glasses actually leave the user in an interesting position to eject the glasses. But what they're actually doing is folding the arms in, and the lens then come forward out and are rejected or ejected from the rest of the frame. And after the glasses are assembled again, the arms act as a locking mechanism for the snap lock design.
even though the lenses are easily thrown away and replaced, there's actually a very sustainable aspect on this product. 55% of the product is the lens, and the remaining 45% is the frame. So when you discard the lenses alone, you end up actually saving 45% of the product and recycling it. The lens, after being ejected from the frame, are a single material part, so recycling them all of a sudden becomes an easier task. For the lens, I did a test for moldability using silicone and polyester resin, and that was purely to see if the product was moldable. I already did tests on SolidWorks, and that gave me digital reassurance, but I just wanted that physical reassurance as well. And the result was good. They didn't come out 100% clear, but that wasn't what I was after. I was doing it to see if gravity could push the resin in place, and after opening it up, it just snaps out. Another project that could go on top of this whole design is a dispenser that could be kept in the break room in these hazardous work environments. The dispenser would make it easier to distribute the lenses amongst the workers and bring convenience with refreshing their lenses, and also act as a reminder as well. If they're going to have a break, they see the snack machine and they might also repair their lenses. The best case scenario for these glasses are that they no longer are a form PPE, that they're actually a tool in the workshop. They're something that you maintain and like sharpen almost, you know? Tools get dull, but you can repair them. That's the next point that I could take on this design, which is to have the frame become like stainless steel, or even take that aesthetically up, because and an even higher point is that the lenses remain the same. The lenses remain the same, but the glasses change, and everyone has their own pair of glasses that fit the same lenses. So